Welcome everyone to this section of the course of working with images. In this section, we're going to focus on learning how to work with images with the Pillow library. We're going to install it with pip install pillow, so if you want, you can take the time to go to your command line and just type pip install pillow to run it. And then what we're going to do is show you in the notebook how to open and save image files with this Pillow library, as well as interact with images, such as grab sections of an image, or have an image overlap with another, or have transparency in an image. Let's get started. I'll see you at the next lecture. Welcome everyone to this lecture where we're going to give a general overview of how you can work with images with Python. So in this lecture, we begin exploring how to work with these images with Python, and we're going to be using the Pillow library for this, which is a fork of the PIL library, which is the Python imaging library. And the Pillow library is really nice with this fork because it has a lot of easy to use function calls. So a lot of functionality is just a simple method call. So what we're going to do is go ahead and install this additional library. So to install the Pillow library, simply open up your command line or command prompt or terminal if you're a Mac OS or Ubuntu user or Linux user, and then just type pip install Pillow directly at your command line. You can find the official documentation for it at pillow.readthedocs.io. Let's open up a notebook and get started. All right, here I am at my Jupyter notebook. Before we get started, I want to recommend that you actually start a notebook in the same folder that we're working with. So underneath the Working with Images folder, you'll notice we have our 3 notebooks that we're going to be working with throughout this section. I started a new one called just Untitled for now by hitting New Python Notebook. But the reason I recommend this is because there's a lot of PNG and JPEG files, essentially image files, that we're going to be working with. So if you don't want to worry about passing in the entire file path because you don't want to get a file not found error, just go ahead and start the notebook in the exact same location underneath this Working with Image folder. Otherwise, you'll need to provide the full file path for these specific files that we'll be working with. And the lecture notebook that goes along with what we're working with here is Overview of Working with Images. So 2 final notes is you should have installed Pillow by now, as mentioned previously. If you have not, go ahead and just run pip install Pillow at your command line. And the second thing is sometimes when you're working with large images, the Jupyter Notebook may complain that your data rate is exceeded. Essentially, it doesn't want to keep sending so much information out to your browser because it's afraid that something's wrong. So the default data rate limit may be too low for some of the images we're working with. If you get this error of IO pub data rate exceeded, don't worry. It's just a warning. All you need to do is go ahead and shut down your notebook and restart it at your command line, command prompt, or terminal by running Jupyter Notebook, and then we add what's known as a flag. And essentially this flag just says that take their notebook application and set the data rate limit to something much higher, which is, in this case, 1 times 10 to the power of 10. So this is essentially maxing out that data rate limit, and then it shouldn't be any issue with you showing very large images in your notebook. So we'll be working with some images that are large enough to really be desktop background images. And luckily, the notebook will kind of resize these automatically for us, but it will still display quite large images itself. So just want you to be aware of that in case you happen to get this data rate exceeded error. You can also just Google search IOPUB data rate exceeded, and it'll link you to a Stack Overflow explaining this in more detail. But for now, let's hop back to this Untitled notebook that we're working with and begin showing you how to open images with Python. So because we're using the Pillow library, recall it's a fork from the PIL library. So even though you install it as Pillow, you actually import it with PIL. So from PIL in all caps, we will import image, so the image object here, or class, and then what we're going to do is say image.open, and this is where you pass in the file path. So if I do Shift Tab here, it's FP, which stands for file path. And what we're going to do here is I'm going to work with the file example.jpg, which recall is located here under working with images. So it's right here, example of JPEG, and we'll assign this, I'm going to assign this to the variable Mac. And something to notice here is the type of file this is. This is a specialized JPEG image file from PIL. So that means there's going to be various properties, attributes, and methods calls that we can do this. Now, if you're running this on a Jupyter Notebook, if you simply type Mac, Jupyter Notebook is actually smart enough to display the image itself. So it should be just a singular Macintosh computer, kind of one of the older models, and then against a white background. If you're running this as a script or in some other IDE, such as PyCharm, you will probably need to do mac.show and run that. So Jupyter Notebook, you just need to type in the variable. Other environments, you may need to type .show, open and close parentheses, in order to see the images. So keep that in mind. Okay, now let's see what attributes this has. There's image information, such as the size, and the size is reported back with width and height. And then it'll also tell you the file name. We technically already know it, but we can call for file name as an attribute. It'll tell you it's called example.jpg. And if you want some more specific information about its format, you can do format description, and it'll tell you exactly the international standard of JPEG it is. Okay, so we know how to open a file now. Let's go ahead and perform some operations on it. We're going to go ahead and show you how to crop the image. Cropping is just grabbing a subsection of the image. And the way we can do that is by calling the crop method off of our variable storing the actual image. We can say mac.crop, and then you'll notice that it expects a box, which is a 4-item tuple defining the left, upper, right, and lower pixel coordinates. This is a little confusing at first, so let's quickly jump to an example of what those coordinates actually represent. Let's imagine that we just had a single blue rectangle as our image. Then what we can do is set the top left corner of this image as 0, 0. And then we can make the x-axis go along horizontally, and on the vertical axis we can call that y. So basically now the first two coordinates in that tuple of 4 are going to be your starting x and your starting y, where 0, 0 is measured from the top left corner of the image. The next two are w and h for width and height, and those are also coordinates. So you would pick the additional 2 coordinates of width and height, and essentially from these 4 items, the starting x and y, and then the width and height coordinates of the actual pixels themselves, then you can end up creating a rectangle and crop out that image. So let's see this in practice now by jumping back to the notebook. So off of this, we will say 0, 0. So we'll start at the very top corner, and then we can say 100, 100 for these starting coordinates of that width and height to be 100, 100. So when we run that, we basically get the top left corner of that Mac picture. If we scroll back up, that's essentially this corner up here in the top left. So the Mac image isn't really a useful demonstration of cropping. So we have another image for you called pencils. So we will say equals to image, open, and we will open pencils.jpg. And if we take a look at what pencils is, it's a very large image of some colored pencils on the left-hand side. Everything else is gray. Let's attempt to grab some of the top pencils from the corner. In order to do this, we need to know the size of the image. We'll say pencils, size. We see it's 1950 pixels by 1300 pixels. So what we're going to do is, if we just wanted, for instance, these top few colored pencils, maybe only up to this orange colored pencil, so the top 3, we're going to start off at the top corner. So we'll say x is 0 and y is 0. And then the width from there, let's go ahead and grab about 10% in the y direction. So we'll say that the width, or actually this is about a third, so we'll say 30% in the x direction and 10% in the y direction. So that means the width is going to be 1950 divided by 3. So we're essentially grabbing 30% of the width here, and we'll grab about 10% of this height. So we'll say h is equal to 1300 divided by 10. Then we will say pencils, crop, and then we'll pass in our tuple x, y, w, h. And here we can see we're able to successfully grab those 3. Now let's imagine we wanted to grab pencils from the bottom. So we wanted to just grab these 3 pencils right here, or maybe these 4. In that case, we'll say x starts at 0, but now y is going to start all the way, so x starting at 0, y is going to start all the way down here, maybe just a little bit off of the height. So the height's 1300. So let's go ahead and say that now if we just want the bottom, this is for bottom pencils, we'll start x0, y is going to be equal to 1100. So we're starting x0, y all the way down here at 1100. And then we're going to go all the way to the bottom for this height. So now we'll say the height just goes to 1300. And then the width is going to be the same, 1950 divided by 3. So we want about 30% of that width coming off of that. So we do this again. And then if we do the same crop, now we get those bottom colored pencils. So again, keep in mind that these are coordinates. It's not exactly a measurement of width and height, which is why h is equal to 1300 here instead of some smaller number. So it's essentially start, finish, and then just kind of start, finish as well. So let's go back to the Mac photo and see if we can just grab the computer itself. So if I say Mac, I have the computer here. Let's see its size. So Mac size is 1993 by 1257. So about the halfway point, we want to grab halfway here and then a little bit off of it. So we can define halfway as equal to 1993 divided by 2. And then we'll say that our x position that we're going to start off at is halfway minus 200 pixels, and that the width that we're going to end at is halfway plus 200 pixels. And then we'll say something like y is 800, and you can kind of just guess and check for these numbers. These are essentially just lucky guesses, except h, because that's all the way to the end. And let's try this. We'll say mac.crop x, y, w, h. And then here we can see that we were able to successfully grab the computer image. Now let's discuss copying and pasting images. If we want to create a copy, what we can do is reassign that crop. We can say computer is equal to map crop at x, y, w, h. And I can call the paste method off of this. And then I provide the actual image. In this case, it's computer. And then where the top left corner is going to go. And that's going to be a tuple of just 2 coordinates. So we'll go ahead and put it in the top left corner of the original Mac. And then if we check out what the Mac looks like now, we are able to copy and paste this to the top left corner. And you can do this multiple times. So if you want one further in, you can define this further in. So we can say 796 or something like that. Run this again, and now we pasted another piece of that Mac. So keep in mind, this is permanently affecting the variable, but it's not permanently affecting the actual image itself. This is all just happening in memory. You can also use the resize method to resize an image. So to show you what I mean by that, if we say Mac size, we right now have 1993 by 1257. If we wanted to make it much smaller or stretch and squeeze it, we can say mac.resize, and you can just choose whatever sizes you want here. For instance, if I want to stretch it out or squeeze it, I can say make it 3000 pixels by 500 pixels, and it will, whoops, let's make sure we pass this in as a tuple. There we go, and it will stretch and squeeze to whatever sizes you want. So you can make it twice as big, half as big. It's really up to you. You just set the new size you want. You can also rotate images, and that's just done with the rotate method. So we can say mac.rotate, and you can rotate by 90 degrees, and then you can see here that we're able to rotate our image by 90 degrees. To finish off our discussion of working with images, let's go ahead and take a look at transparency. Here we can see that a lot of images have a red, green, blue, A, or RGBA system, and that stands for red, green, blue, alpha. And all the values of red, green, blue, and alpha can go from 0 to 255. If the alpha value is 0, then the image is completely transparent. If it's 255, then the image is completely opaque. Let's explore this idea of transparency by opening up 2 images that we have for you. So these are in your Blue Mission folders. We can say image.open. We have a red color JPEG. So if you take a look at it, it's just a red square. And we also have a blue JPEG for you, which is going to be equal to image, open, and we will open up that blue color PNG. And now we can see we have a blue there. So if you want to reset the alpha on one of these, you can say put alpha and then pass in some integer value from 0 to 255. So if you pass in 0, it means it's completely transparent. So now I only see white because the background is white. If I reset the alpha to be 255, completely opaque, and I run this again, then I actually see the blue. If I choose somewhere in between, has to be an integer, so for example 128, then I get back this sort of lighter blue. Here we can see that some white has now mixed into this blue. And to get an idea of what that looks like with red, let's say red, put alpha to about 128, and check out what red looks like now. Now it looks even a little more pink. And now you're probably wondering, how can I actually mix these two together, this blue and this red, to get something like purple? Well, you can do that with the paste functionality, which essentially pastes one image on top of another. Pasting one image on top of another when the top image is completely opaque will essentially just hide the image underneath. But since we've added transparency with this put alpha, we will actually be able to see basically half of the bottom image and half of the top image. Let's go ahead and do that. If you say blue paste and do Shift Tab here, it basically takes the current image object that you want to paste on top, the box, which is essentially how you want to line this up, if you want to line it up to the center or to the top left, etc. So it's essentially the same kind of XY mapping that we saw earlier, and then the mask. And the mask should essentially be the same as the image. If you want more details on this, you can check out the entire docstring, but essentially the way to remember this is what is the image you want? So the image I want to put on top of blue is red. How do I want to align it based off that top left? So we'll say box is equal to 0, 0. Essentially align it with the top left corner. Alignment and the box parameter become important if you have two different size images, but in our case red and blue are the same, so we'll just set it at 0, 0. And then mask is going to be the same as this image, which is red. So we have image is equal to red, box lined up on that top left corner, and then mask go to red. Let's go ahead and run this, and then check out what blue looks like. Notice this is all happening in place, and we get something that essentially should look purplish. Okay, so we just got back an image that looks more purple, which means transparency and masking can actually be kind of more complex than what we've shown here. Is a really simple example. You can check out the Read the Docs Pillow documentation link that we discussed earlier, but for most use cases, just knowing your images and then where you want to place them should be enough, depending on what the exact situation you're trying to achieve is. All right, finally, let's show you how to save this image. Imagine you really like this new kind of purplish object, then you simply say blue, save, and then choose the full file path, or if you want to save it at this location, just whatever you want to call the image. So in this case, we'll call it purple PNG. And keep in mind, you could also do something like C, users, etc. So wherever you want to save it, you can pass in that full file path. And then I'm going to save it as purple PNG. Let's go ahead and make sure that worked. I'll say purple is equal to image, open, and let's open up that new file, PNG. Check out purple, and there it is. Keep in mind that running save like this will immediately overwrite whatever file is called purple.png. It'll create the new file if it doesn't exist yet, but if purple PNG already exists, then saving it with this file path will actually cause an overwrite. So just keep that in mind. Okay, great work. Now it's time to test your new skills with an exercise. I'll see you at the next lecture. Welcome back, everyone. It's time to test your new skills with an exercise. So this lecture will just give an overview of what the general exercise is. This one's a bit more like a puzzle, and it's more open-ended, so we won't give you too much guidance. But if you get stuck or get lost, you can go ahead and check out the solutions notebook or the solutions video, which is up next. But for now, let's do a little bit of an exploration of that image exercise overview notebook. I'm going to go to it now. All right, here's the image exercise notebook. So notice in the folder, Working with Images, which is the same folder this notebook is located in, there's two images we're going to be working with. One is called wordmatrix.png, another one is called mask.png. So these are located right here, Working with Images. There's right here, word matrix, and then mask. So these are the two we'll be working with. And the word matrix is a PNG image file that essentially looks like this. It looks like a spreadsheet of words. And then the mask image file looks like this. So what we want you to figure out is essentially how can you work with these two images to attempt to reveal what is essentially a hidden message in this spreadsheet. A couple things you have to figure out are how to stack these images on top of each other, whether you need to work with transparency in order to see through the images, as well as maybe resizing the images. It looks like these images currently are not the same size. So again, this is a little bit more of a puzzle. It's open-ended, so I don't want to guide you with steps to give you too much information. Instead, really let yourself explore and try to figure things out on your own as if this was a real-world puzzle situation. Okay, so again, you have these two images. There's a secret message that you will be able to reveal if you can figure out how to connect these two images together. I'll just leave it at that. If you get stuck, feel free to move to the next lecture where we'll slowly go through the solution process. Thanks, and best of luck. Welcome everyone to this lecture where we're going to go through the solution for the image exercise puzzle. Let's get started. All right, here I'm at the exercise notebook. Recall that we essentially gave you these two images and left it up to you to figure out how to reveal the secret message. I'm going to just delete these cells and then start off by importing both images. So I will say from PIL import image, and now let's actually open up those images. I'll first do the words, which is image.open, and since I'm located in the same folder as that PNG file, I'll simply say wordmatrix.png. You should be able to just tab autocomplete this. And then the next one I'll do is the mask file. So I will say mask is equal to image.open, and this one is mask.png. And I can check them out. Here are the words, and then here is the mask. So if I try to just directly paste the mask on top of the words, it won't work. And let me show you why. Because even if I just say words.paste mask with the box at 0, 0 and the mask, and then check out words, well, I have a problem. One is they're not the same size, so it doesn't really reveal everything. And the other one is that words is completely opaque. There's no transparency. So that means there's two things I first need to do. I need to resize one of these to fit the other. It probably makes the most sense to resize the mask because I'll probably get some errors. Well, not really errors, but it might blur the words if I try to shrink them too small. So it makes more sense to enlarge the mask to the size of the word matrix. Then the second thing I need to do is to actually add transparency to the mask in order to see through it to see what words are being highlighted in these white boxes. So let's go ahead and do that. First, because I accidentally kind of transformed the words, let's come back here and re-import both of them to make sure words is working and mask is working. Perfect. Let's go ahead then and resize mask to the size of words. To do this, I'll simply check what size words is. So let's check word size. It's 1015 by 559. So I will take my mask and set it equal to the resized version of 1015, 559. And now my mask size is the same as the words. Next, I need to add transparency. So mask.put alpha. And really you can put this it's up to you how much alpha you want to put in. But I found 200 was a value that worked for me. So if I take a look at mask now, you should notice it looks a little grayer. So this should be enough alpha for me to see the words through it. So let's try that pasting again. I'll say words, paste, the mask, line up at the top left corner, mask again, and now let's check out the words. We run that, and here's the result. So you should have been able to see, great work with images, you are the best. So those are the highlighted words. Okay, I hope you enjoyed this one. It's a little more like a puzzle than just kind of a guided exercise. If you have any questions, feel free to post to the Q&A forums. If not, we'll see you at the next lecture. Thanks.